My name is Yodit. I am a software developer and machine learning and kind of maths, I suppose, background. And nowadays I run OpenSensors.io. We're a small company based in the Open Data Institute in London. And really what we're building is messaging for public data and private data for sensors. So we're kind of real-time middleware. And really what we're trying to say is the fact that with the Internet of Things, and especially smart cities and buildings and so on, the data has to be reusable. Like a lot of these sensor deployments are very, very expensive. And I think Dame Wendy talked about it earlier, is that they're sitting in silos at the moment. And what we're trying to do is kind of break down these barriers. On the open data side, we process something like 6 million or 7 million messages a day. A significant amount, and a lot of the people that are publishing data actually are coming from the private, I suppose, enterprise, individuals, hardware manufacturers, and so on. So we've been going for about a year and a half, nearly 2 years, and since then, we've got nearly kind of complete coverage of European and North American air quality data published privately by hardware manufacturers, some kind of scientific institutions and so on. A lot of data around earthquakes, a lot of like shipping information, flight information and so on. And what we'd like to do is get people to reuse them. And obviously, when you're building kind of quote-unquote smart objects, the data from the public side, like air quality data inside a building, is actually affected by air quality data outside a building. So only when you start stitching these things together do interesting things happen. And we're seeing quite a lot of really interesting projects coming out of all of this. Just to kind of give a little bit of context, I'm going to hit on some of the technologies we use and some of the technologies that seem to be getting traction for the Internet of Things. Just as a bit of scale, I mean, Internet of Things is a messaging issue, right? We are dealing with insane quantity, like large amounts of messages. The predictions are supposed to be, Twitter, I think, processes something like 6,000 or 7,000 messages a second. We're predicted to see about 300 times those amounts. So huge kind of really kind of interesting middleware challenges. We're used to building large-scale web services, but actually kind of the real-timeness aspect and millions of people publishing data and millions of potential subscribers brings its own kind of interesting challenges. So we have, when people talk about the Internet of Things, usually there's two subsets, I suppose. There's the machine-to-machine automation, which is, as the kind of the Sam Labs guys showed, there's an actuator, there's a sensor, and you do something on data. So you can say, a lot of the agri-tech farms are saying if you put in, soil moisture sensors, if the moisture levels go under a certain amount, turn on the sprinkling systems. And these are kind of sensor and actuator problems or projects. And there's also machine to web. So you then, when you're taking data and you're actually kind of like the Fitbits of this world, you're exposing some visualizations or some kind of intelligence. And how do you do that in terms of machine to machine? You kind of have what I'm seeing a lot of, especially in buildings, is digital concierge services. People are starting to install lots of footfall monitors or things like beacons, and they're really kind of trying to be a bit smart of how they can manage spaces. And that has obviously commercial reasons, because for example for London, I think each desk space in central London costs something like 12 grand a year. So being able to optimize how you use office spaces and workplaces is interesting. One of the first projects that we got involved in was fall detection. So enabling a research institute to create a wearable system that had accelerometers and so on, and can we detect flaws in real time? And that's a pretty major problem. And it was, in terms of algorithms, it was actually not hard at all. I mean, most people could do it. It's just the scale of the data that they can cope with. So real-time kind of algorithms are extremely important. Just as going into the protocols a little bit, because I just want to set the context. There's two, I suppose, there's three kind of, I suppose, data transfer protocols for the Internet of Things that I'll talk about. The first one is co-op. The second one is MQTT. HTTP is used quite a bit, but HTTP has constraints. I'm not going to touch on it too much, but just to set kind of to say why, HTTP comes in with quite a lot of headers, and if you have sensors with a limited amount of bandwidth and power, you really need to optimize the messaging. So the messaging has to be tiny packets transferred over the wire. And what really is seems to be the two most popular ones are co-op and MQTT. Now, co-op is basically HTTP Lite, so you can set get and put requests and so on. And so they've cleared out all the headers, and they're just it's RESTful-like. It's over UDP and really quite simple. I mean, people that are used to building web services can get started very, very quickly. MQTT kind of is a publish and subscribe model. So you have lots of sensors and lots of sensors or web services that are subscribing to the data, and it's completely decoupled. So as a sensor, I don't really care who's listening in. I'm just going to publish messages, and it's data is sent over TCP, and really it's kind of super optimized to be for low bandwidth devices. It's been around for quite a long time. It was open. The specification was open sourced by IBM probably about 15 or 16 years ago. And it is kind of works beautifully for quite a lot of messaging. We're doing a project with parking sensors at the moment for some smart cities projects, and it works beautifully. And I've seen it used for kind of communication with. There's some communication over for health wearables, and I think it's I can't remember the hospital name, but they're using it to monitor patients from home. And just as a bit of, I suppose, context, then you can start adding in logic. There is an open source kind of wiring tool called Node-RED, and this is a project done by somebody from the community. So they started taking the earthquake data that we're publishing, and they started actually saying, well, if there is an earthquake in certain places, email me or alert me. So just like the SAM Labs, you just can start. You can start without really necessarily kind of getting into the nitty-gritty of the devices and the protocols. You just start wiring functions, and then all of the functions are just JavaScript functions, and the community they kind of they put in lots and lots of flows are actually exist already. So if you don't want to, if you can't program, it's actually hugely easy to get started. I've covered the machine to website. So what I want to go back to is kind of the why open data question. So why do we feel that open data is going to scale IoT? And I feel quite strongly about this. And I think just for those of you that are not familiar with it, open data says, just like open source, you can reuse the data without restrictions, and sometimes people ask you to attribute it back to them, so you can say, I've got it from this place. But that's it, really. It should be available to everyone. And it really, what it does is it reduces the risk and the cost of execution. So for a lot of the smart cities projects especially, we're seeing kind of large multi-million pound projects being deployed, and if you're talking about these things being in silos, you kind of have to redeploy them over and over again for different use cases. And what we're trying to say is, well, actually, if there's a commons for the data and people can easily share and reuse the data commercially or privately, then we can iterate on it, and we're not kind of stuck in this in these early days. And with open source, again, there was kind of this explosion as open source proliferated about over the last 10 years. We have come such a long way, and that's really what we would like to create for IoT. So data available, as I said again, earth quality, weather, flights, and so on, and really quite interesting projects. I mean, there's people sharing kind of their energy usage data and starting to stitch that together, and we're kind of seeing things that I never really thought. Well, I never really had the use cases in mind. So this is one interesting project that, with the third runway debate in Heathrow, some interesting kind of community movements started happening. One of which is the fact that the actual DEFRA air quality monitor, for some reason in January, was turned off, and the residents were really upset about this because they wanted to present their case for and against. Or usually against the third runway, and there was no data to base their kind of arguments on. So about 20 volunteers installed some air quality and noise sensors in their gardens, and they've kind of come together under this project called Breathe Heathrow, and the data's published. The data's available now, and it's an interesting one because. And it's also kicked off other projects in Toronto and another one in London called Air Public. And and lots of people are starting to analyze this data. There is 4 PhD grads that are spending a month just understanding the data. Some journalists have offered to pay for more sensors and install it. And this is data that really should be available already. You'd think it would be available, and somebody has it somewhere. But because of it's just the simplest thing. It's just, can we get some raw data around it? Other open data projects are. That we help enable is air quality egg, so you can buy one of these, and so you can understand the air quality in your homes and wherever, but also the data is published. So there's a network of air quality eggs, and you can really kind of look around and understand in the context of your space, how you're doing against kind of other places. And there's a really vibrant community around this. Oxford Flood Network is one of the earliest, I think it's kind of an early project, but they're putting little sensors under bridges, and really for people it's just, is my house going to get flooded or not? But on a macro level, actually this data is quite interesting. And again, this data might exist somewhere, but it's not available, and people really care about these data sets, and they care about small amounts of data sets that actually affect them in some way. So that is me. Thank you very much, and I hope that was helpful.
Thank you, Yodit. That was a very interesting presentation. We have time. I think
we do have time. We'll delay the start of the next session until at least 1:55.
Thank you.
I think that's right. Yeah.
Okay, so we've got time for a couple of questions. Has anyone got any questions for Yodit?
Well, I have one. I had to go out to make sure it was okay to delay. Are the devices that you were talking about already available, or are you gathering information from other devices that you don't make?
We don't usually make any devices.
Don't make any devices. Okay.
But we work with the hardware manufacturers for either public or private devices and they basically sell their devices.
And they offer to make this information available publicly, so you're taking advantage of that.
Yes.
Terrific.
But some are private, and we charge the private folks.
Is there a website that we should go to? OpenSensors.io?
Yes, that's right.
Okay. One more. Thank you.
And find data.
You spoke about the the need to fuse both public and private data, and the air quality issue was a great one. How do you incentivize private data owners to release data to you? And is there any way to, in essence, sort of parameterize data rather than having big data sets publicly available to everyone?
So in terms of incentives, we don't really. I think what we try to do is take people along with us. I think showing the advantages and people's kind of, I suppose, excitements, and that's when people's eyes light up. Really, can you help me? For we deal with lots of utilities companies, and there's a lot of can you help me route my road gritters efficiently if I know where people are and so on. The challenge with IoT is actually there is no standard for this stuff. Not in terms of the communication standard, but actually I'm more worried about the schemas and how do I know when I get a light, if something says it's a light, how do I know it's actually a light, and what does a light sensor actually publish? For pollution, we get a lot of pollution data, but actually, is it PM10, PM25? I mean, there's so many, these kind of specific, I suppose, measures that are not standard, and we're starting to try to calibrate, at least for pollution, because we've got a lot of that kind of data, and saying, well, here's your pollution data for this particular kind of geocoordinate. But it's really difficult. It's early days, and it'll come, hopefully.
Should we take one more? Let's take the one back.
Hi, Yodit. What's your business model today?
So anyone publishing and subscribing to open data can do so for free. It's the private data hosting that we charge for. So usually quite a lot of we have clients that are much more kind of utilities and buildings kind of clients, and they're starting to combine the data sets anyway. But it's all the private hosting that we charge.
Great. Well, thank you very much, and thank you to everybody who attended the session.
Yes, we should return.